So, welcome to another video lecture on digital principles and computer organization. So, in this video, we are going to discuss about instruction execution. So, now let us discuss about how the instruction get executed with few example with instructions based on the risk state. Risk means reduced instruction set computer. Let us now discuss about load instructions. Consider the instruction. Here we are going for load R4, x of R5. This x of R5 representing the index addressing mode. So here we are loading a word of data from the memory location x plus R5 into the register R4. So what are the steps which is involved in the execution of this above instruction? The first step is instruction fetch from the memory. So first the program counter PC which contains the address of the instruction, that is load R4, x of R5. So this instruction, this address is sent to the memory address register, which is defined as MAR. Then the instruction is fetched from the memory and it is stored in the memory data register, which is defined as MDR. Then this instruction is moved into the instruction register, which is defined as IR. Later, the PC get incremented to point the next instruction. So the second step is decode the instruction. So the control unit which will decode the instruction present which is in the instruction register IR. It identify whether the operation is a load and it will check for the addressing node whether it is direct addressing, indirect addressing, etc. Then it determine the source address x of R5 and destination address. So here it is R4. The third step is compute the effective address. Let us fetch the operand. It is an optional one. Why it is optional means here the address part mentioned here is either it should be of indirect addressing. So what I mean is the address is not specified here. So the address part of the instruction x of R5 is which is placed in the MAR, right? So if the instruction was indirect addressing only, the effective address is fetched first. So here the effective address is equal to EA, that is the content of the resistor. Here it is R5 plus offset value. So this is the this is how the effective address get fixed. So the hardware event involved in this is arithmetic and logical unit, because for addition we require arithmetic unit, right? So again, if we see if the address is directly there in the instruction means there is no use of computing the effective address. This step is completely avoided. The fourth step is read the memory source operand. So the memory at the address x of R5 is accessed and the data is loaded into the MDR. Okay, and the fifth step is execute the instruction. So which means load the operand into the destination register. Here the destination register is R4, right? So the data from the MDR is transferred into a specified register. Here it is R4, right? The last step is update the status of the PC. It is the status flag may be updated. It's optional one, and the program counter should point to the address of the next instruction, which is already it has been done. So let me overview this one. First, the piece from PC, the address is So from the PC, it is loaded into the address is loaded into the MAR. Then the instruction is fetched from the memory and it is stored in MDR. Then it is the instruction get moved to the instruction registers, right? The second step, the control unit will decode the instruction part, which is present in the instruction registers, in order to identify whether the addressing mode source address and destination address. So if this is the optional part, if address is there, there is no need. So if address is not there, then we have to compute the effective address. Then it gets stored in the MAR, right? So in the next step, where is reading memory source operand. So from the MDR, it has to from the MAR, it has to go to the MDR, right? So the last step is from the MDR, it has to go to the power 4. Okay. Next, last step is the PC and the flag should be get update. Now let us discuss about how to execute arithmetic and logical operation, which is similar to that of the load instruction, but it differs in two ways. One is it either uses two source registers or one source registers and the one immediate source operand. So here there will be no access to the memory operand. So that was a difference. First, we will discuss about one an instruction add R3, R4, R5. So here what it is doing is the first step here is fetch the instructions and increment the PC. This is similar to that of the loading section. Like so the address from the PC is loaded into the memory address registers. Then it is get the data, the instruction is then it is loaded in MDR. Then it is go to the instruction registers. After that, the PC get incremented, right? So the second step is decode the instructions and read the content of the source registers. Here the source register is R1 and R5. So in order to decode the instruction, we are using the control unit, which decodes the instruction and the instruction registers to identify whether it is AND operation or operation or add or subtract, etc. Like etc. And it is also used to identify registers or operand, that is here whether you are using R4, R5 in the R6, right? So the third step is compute the sum R4 plus R5, right? So if the operand are in the register, then so here you can see the operands are registered, right? So it will send directly to the arithmetic and logical unit. Suppose if the operand are in memory, then the effective address is calculated and the value is fetched into the MDR. Then later on we have to execute the ALU operation, which is specified by the instruction R4 plus R5, right? So the fourth step is store the result into the destination register. Here it is R5. So the output from the arithmetic logical unit is transferred to the destination registers. That is here is R5. So what will be the last step? The last step is to update the status flag, which is based on the result. Suppose if 0 is set means you have to change it as to 0. If carry is set means carry has to be changed. Next, let us discuss about the store instruction. So here the store instruction is store R4, X of R5. So this is similar to that of the load and arithmetic section, but here in the load we are loading the data from X of R5 to R4. but in the store we are storing the data from the R4 to X of R5. So here it is nothing but an index addressing mode. What are the steps involved in the execution of this instruction is first one is instruction fetch from the memory, which is similar to that of the load instruction, where first the store instruction is store instruction address is determined by the program counter, right? It is the program counter only, it contains the address of this store instruction, and this address is sent to a memory address registers, right? So this instruction is fetched from the memory, and it is stored in the memory data register, and this instruction is moved into the instruction register. So on the PC it goes to MAR, then MDR, then this goes to the instruction register. Later on the PC get implemented, right, to the next instruction. Next is decode instruction. So it consists of a control unit which will decode the instruction which is present in the instruction registers, which will identify whether the operation is stored or load. So here it is load instruction, and it is find out the addressing mode, which is indirect addressing or index addressing like that, and it is also determining the source address, which is source address of R4 and the destination address of X of R5. Third one is compute the effective address. So here the whatever the instruction register, it get decoded by the control unit. And the third one is computing the effective address, which is an optional one, which fetches the address part of the instruction, that is here X of R5, which is nothing but the indirect address node, right? So it will fetch the address of the X of R5 and it move to the MAR. So for example, R5 plus this offset value, so this is the address. Okay. Next one is read the memory source upfront. So here the data is there in the R4 register, which is moved to the memory data registers. So the whatever the R4 value get moved to the MDR. And the next step is execute the instruction. And what is the execution of instruction is which is store the operand value, the R4, into the destination address X of R5. So the MDR value get stored in the NAR. So MDR is data of R4 that is stored in the MAR. That is address of the X of R5, right? Last step is update the status of the PC by updating the status flag. It is option 1.